In this video, we are going to see about lines. Previously, we have seen about edge reduction as well as edge linking, which is a continuation of this. You may see multiple curves or so much of curves in natural objects like mountains or whatever may be the object created in real world or the nature represents the curves. But the man-made objects or more are like buildings or documents have lots of straight lines than curves. So detecting and matching these lines is useful in things like architecture modeling, camera pose estimation in cities, document layout analysis. To do this, we can use three approaches. One is successive approximation, next one is half transform, and third one is vanishing points. We'll see all the methods in detail. First one is successive approximation. In successive approximation, a curve can be represented by series of 2D points. I'll show you with a simple mathematical example and then we'll proceed further. So consider I'm going to have an edge. This is my x-axis. I have a points 0, 1, 2, 3, 4, and here I'm going to have a value 0 0.2, 0 0.5, 1, and 2. I'm going to have 5 values, 5 edge points 0, comma 0, 1, comma 0 0.2, 2, comma 0 0.5, sorry, 2 comma 0 0.5, 3 comma 1, and 4 comma 2. These are the edge points I'm going to consider. Okay, so 0 comma 0, 1 comma 0 0.2, 2 comma 0 0.5, 3 comma 2, and 4 comma 2. This is my edge points. So I'm connecting it so it produces an edge. This is obviously not a straight line. Okay, the first step I'm going to do is I'm going to draw a straight line out of it. Okay, draw a straight line connecting the point. Okay, 0, 4 comma 2. This is not exactly right. So we have to connect this 0 comma 0 and 4 comma 2. I'm going to draw a straight line, right? This. So the first step is to draw a straight line by connecting the two edge points. Next step, I'm going to find the 0 comma 0 and 4 comma 2 are my final points. We know that a line can be drawn with 2 points. One is x1 comma y1, another one is x2 comma y2. The edge points are x1 y1, x2 y2. So in this case, the edge points are 0 comma 0 and 4 comma 2. I'm going to take as b and a. Next, what we are going to do means I'm going to find the difference between b and a. So b minus a gives 4 minus 0 is again 4, 2 minus 0 is also 2. Next, determine u vector, which is root of 4 square plus 2 square. I'll get around 4.4 some value. Next, we need to identify the intermediate points, distance between the point 1 and 0 0.2 to this line, and 2 and 0 0.5 to this line, 3 and 2 to this line. I am going to find the distance between these point as well as the line edges. Okay, so how to calculate the distance means I will have certain formula there. The distance d is calculated as first take a point 1 comma 0 0.2. Distance d would be determinant of 2 into 1 minus 4 into 0 0.2. This 2 and 4 are nothing but the values of b minus e. Sorry, this is nothing but the values of b minus a is 4 and 2. Now the point taken is also 1 and 0 0.2. So subtract 2 into 1 minus 4 into 0 0.2. The next step would be divide the same with 4.47, this value. You will get the approximate value of 0.26. Find the next intermediate point. Second intermediate point is 2 and 0 0.5. The next point distance would be 2 into 2 minus 4 into 0 0.5, similar to this one. Okay, only these points are changed. So 2 into 0 0.5, same 4.47. I'll get the value approximately more or less equal to 0.44. The next step is to identify the distance between the remaining point, that is P of 3 comma 2, distance of P3, that is point 0.1, point 0.2, point 0.3 equal to 2 into 3 minus 4 into 2, 4.47, which is equivalent to 0.4472. Here also 0.4472, more or less they are same. Okay, first what we have done, we have taken an edge. By considering the end point of the edge, we have taken a line. The next step is to find the distance between intermediate points to the line. We have done. Again, next we have to find the maximum distance. Maximum distance point here is first point distance is 0.26, second point distance is 0.4472, third point distance is second 4.0.44. Both are more or less same. So I am going to take the first one. I am considering the maximum distance point is 0.447, which is available in P2 as well as P3. I am taking the first one, P2. What is the conclusion or inference of identifying this maximum distance is this P2 is a point that is producing a more wind when compared to all other intermediate points. You see here, in this edge, the point P2 is provided more edge. This length as well as this length is more or less same. So this is the point that is providing more edge. So I am going to divide. This is the much more bend is provided. So I'm going to divide this continuous edge into two edges. Now the edges are divided from P0 to P2 and P3 to P4 because we have found that P0 is a 0, comma 0, P1 is 1, comma 0.2 and P2 is the maximum distance. Now my entire edge is now divided into two parts. One is 0, comma 0, 1 comma 0.2 and 2 comma 0.5. This is my edge 1 now. The next part would be 3 comma 2 and 4 comma 2. This process is again repeated. Now I will take 0, 1, 2, 3. 0 comma 0 will be my edge 1, 0, 1 comma 0.2 and 2 comma 0.5. So I consider this edge. Now in this case 0, 1, 2, 3, 4, 0, 1, 2. So 3 and 2, 4 and 2. This will be my edge 1. Okay? This process will again be repeated. So I will take a straight line out of this and I'll find the distance between this. Here also I will take a straight line out of this. I'll find the distance. The same process will be repeated until every edge is converted into a single line. This process is known as successive approximation. Here we are converting the edges into a straight lines. Okay, so this is a successive approximation technique that is what mentioned in your algorithm also. Let us see the steps given here. They are drawing a straight line between the two endpoints of the edge, finding the point on the curve that is farthest away from the line. We have found the bend, right? The point P2 which has provided the much more bend. We have found the distance max, right? So the finding the point on the curve that is farthest away from the line, which would be the uh, point which is contributing more bend to the curve. So we are dividing that to make it as a straight line. Okay, splitting the curve at that point and repeating the process until the curve is simplified enough is known as successive approximation provided by Damer-Douglas-Eckert algorithm. Okay, this is the given image. This black color curve is the original curve. We have found that line and then we are dividing the curve into two parts first, and this green color line will be curve 1 and the second part of the curve is again a green color line. This green color line is again divided into two parts, which cannot be further divided. So this is a straight line, this is a straight line, this is a straight line. So we have to repeat until we are getting the straight line except the edges. This is the final result. The curve bend is now defined as a straight line. The next part is B-spline. After dividing the edges into line, we are applying a slight smoothing that is called as B-spline. Okay, polyline means we are identifying the line segments inside the edge, and B-spline means after identifying the line, we are providing some kind of approximation to look like a smooth edges, that is known as B-spline curve. This is the first one. We are going to find the line from the edges. So the edge reduction is the first step. Okay, if you have image, you are going to apply the edge reduction technique which was seen in the previous videos. After deducting the edges, we are going to make it as a straight lines. And the next one is Hough transform. In Hough transform, uh, yes, while detecting the lines in real images, they may appear as a broken features. The edges may not always be continuous. We may have broken edges also. If you have broken edges, the Hough transform technique can be used to find the straight line. So let us see an example again, and then we'll come back to an algorithm. We always know the straight line equation is y equal to mx plus c. If your edge is broken, this equation cannot be suitable. So I am going to take equation x cos theta plus y sin theta. Okay, this is the equation. I am going to produce a line, and we are going to take 2 and 3 values. Okay, x comma y is a point and theta is an angle. If I am going to take the angle as 0 degree, assuming a curve edge. Okay, I'm going to take up any point 2 comma 3 in the edge, right? So for the point 2 comma 3, I'm going to find the theta 0. So x would be 2, y would be 3, cos 0 and sin 0. I'm going to find the rho value, which is 2. I'm just randomly taking it. Okay, and then I'm going to change the theta value as 45 degree. So rho would be somewhat different value. So if I'm going to take 90 degree, so 2 into cos 90 plus 3 into sin 90, I'll get some other value 3. So what we are going to do here is I'm going to take a 2D matrix. This is known as accumulator array 2D matrix. I am going to consider for 2 comma 3 a point 2 comma 3 if the theta value and rho value is mapped as a matrix, right? So if the theta value is 0 and rho, sorry, if the yes, yes. And the row value is 2. I'm going to make one node. Okay. For theta value 0 and row value 2, I'm going to take a bin here. I'm getting 1 volt. And for the theta value 45 degree and the row value 3.5, I'm getting another 1 volt. Similar for every theta and row, we are getting a value which is available only once. So I'm making a point 1. So if you are going to take one more point, that is for another edge 4 comma 6. Okay, assume another edge point. Here we have multiple edge points, right? So if 4 comma 6 is taken, I'm going to take the same formula. So 4 into cos 0 plus 4 into, sorry, 6 into sin 0 will provide so and so row value. I'm going to take the row value as 4, just an assumption, and theta equal to 45 degree, which means the row would be 6, or theta equal to 90 degree, the row again may produce 3, just an some assumption value. So here in this case theta and 4 will get some other value that is not equivalent to 2. So theta and 4 gets plus 1, plus 1 volt here. So theta 45 degree and row 6, theta 45 degree and row 6 means it produces a 1 volt. This value is not available. Theta 90 degree is always having a value row 3. So we will get 2 volts here. If theta value is 90, already this produced 1 volts, and now also I am going to take the second point and theta 90 degree produced 3 means I get 2 volts. Similarly, the 2D array will be created. The which bin is having more vote is considered as a possible line. This is what how Hough transform works. Let us see the algorithm. You will get better understanding of that. Um, Yes. So every line is taken with theta and d value. It is not taken with slope and intercept. Theta value is represent the angle of line's normal vector. D is the perpendicular distance of the line from the origin. And every theta d will produce is a sinusoidal curve. Okay, the voting happens in this theta comma d space. The accumulator array is a half space and theta comma d space, and the peaks in the accumulator corresponds to the director one. The peak which we said is the maximum voting, right? So consider this point. This is a kind of edge or so and so. I'm going to take every point. For every point, this green is a point, red is a point, and blue is a point. For every point, on applying multiple theta and multiple d, we are getting 3 different curves. Okay, this green color sinusoidal curve, red color sinusoidal curve, and blue color sinusoidal curve. The edge point, the intermediate point, right? The point in which all the three curves get intersected is known as the point which is available in the line. If you take this point, assuming we are going to take this point may produce some other curve, but it will not intersect. So I can say that the point taken here is not available in the edge. Okay, so see this algorithm. First, we are going to create an accumulator array. Yes, one more point we have to say. The formula we have taken is x cos theta plus y sin theta. We have to look through all the theta and d, all the theta. If you know the orientation, then you can change the theta as tan inverse of ny and nx. So, if you are aware of that orientation, which means in which direction it is passing through, I can take the theta as tan inverse of ny by nx, ny and nx are edge normals. So the equation will be changed to x nx plus y ny. We have taken rho that is represented as d, which is just nothing but a distance between the point to the edge, and increment the accumulator corresponding to theta and d. Here we have seen, right. In case of first edge point, we have, see here, in case of first edge point, we have taken theta 0 and we got a different distance. For theta 2 comma 3, for theta 90 we got t. For another edge point 4 comma 6, the theta 90 we got again the distance 3, means we have got two votes for theta equal to 90 degree and distance equal to 3. So in this case the voting will happen. The voting will be accumulated. We will find the peaks in the accumulator. In the accumulator array, we will check which bin is having highest vote. If you have only one vote, means then that is not a point corresponding to the line. The bin which is having more number of voting is considered as a line, right? So alternative representation means the standard half uses only the 2D representation, will focus on angle and distance. Another option is we can go into 3D, we can consider nx, ny as well as the distance. The next process of transform is cube representation. In cube, we'll have six faces, right? In cube, we'll have six faces. We have to convert the cube 3D into 2D representation. This is the 2D representation of the cube image. I'll show you another mathematical example to map the cube into 2D space. Let us see the cube map representation. Cube map representation in 3D. 3D means we'll have three values x, y, z, 2 minus 1 and 0.5. I am going to make it as 2D. 2D means I have to only 2 points x and y. Okay. Take the large component. Take out the large component here. The large component is 2. That is x, and the largest component is 2. The remaining two components are y and z. Find the value. Y is 1 by 2, u is 0.5. What we have done is u and v. Divide the remaining large components. Right? So dividing the remaining with the large component. Y divided by x and z divided by x. It provides minus 1.25 and 0.25. Now we are going to remap this value to 0 to 1. Remap the value to 0 to 1. How we are going to do remapping means s equal to u plus 1 divided by 2, t equal to w plus 1 divided by 2. U plus 1 divided by 2 means we got u as minus 0.5 plus 1 divided by 2. We get 0.5 divided by 2, which is 0.25. Here w plus 1 divided by 2, 0.25 plus 1 divided by 2, 1.25 divided by 2 will be 0.625. So if your image is 5,1 cross 5,1, 512 cross 512 dimension, mean we'll take the value from 0 to 55511. So because we have found the pixel indices, if the value is remapped to 0 to 1, we are going to find the pixel index. Pixel index can be identified by Px equal to S into 511. The S we have got as 0.25 into 511. Similarly, the pixel Y can be identified as T into 511. T into 511, which is equal to 0.25 into 0.625 into 511. We will get another value. This value will be the pixel index of the cubic representation. So we got two values, which is nothing but the 3D representation in is converted into 2D point. So this is a way of converting 3D point into 2D point. We have six faces. All the six faces are mapped into the 2D. If you are not worried about the magnitude, okay, magnitude in the sense we had a point -1, right? So if you are not worrying about the -1, then we can map the cube into three faces only. So every cube is represented as six faces. Subspace 1, 2, 3, 4, 5, 6 is given. Positive face, negative face is there. X means we have positive x-axis, negative x-axis. Y means we have positive y, negative y. Z also, Z is used to represent forward or backward. So cube has six faces. In order to represent the six faces, we need six subspaces in 2D form. If you are not worrying about the negative axis or down axis or forward and backward, we can have only three subspaces. Okay. So in previous example, we have taken 2, -1 and 0.5. That is, we have considered 2 as a maximum value. If your value is -2, 1 and 0.5 means we would have taken the 1 as a maximum value because -2 is negative value. So the entire representation would be changed again. But if you are not worrying about the magnitude, if you are not worrying about the positive or negative side, then again we'll consider -2, 1 and 0.5 as positive value only. The same process will be repeated. If you are worrying about the sign, if you are considering the sign means we'll consider all the six directions. If you are not considering the sign means we'll consider only the three. So Hough cube representation. Hough cube onto three subspaces. If you are omitting the sign means we can represent only three space. If you are considering the positive negative sign means we have to consider both positive x-axis, negative x-axis, positive y-axis, negative y-axis, forward z-axis and backward z-axis. So normal cube can be as such mapped into 2D by using six directions. If you are omitting the magnitude, we can represent only the half of the cube. Only the positive signs can be represented. So all the six phases is shown here. Only the three phases shown here. The next one is ransack based line detection. Ransack based line detection means it is a random census algorithm. It will randomly pick two edge points and I'll make a line guess and check how many other edges fit. Okay, inlier concept is used here. I'll show you a very simple example to understand. So consider a graph here. We are having a edge here. Again, we are going to convert it into straight line using ransack. Okay. So in ransack, I'm going to randomly consider the edge points. I'm going to make a line out of it, and find the distance between this. If you are going to identify the line here, we'll have certain values. So also formula will be used. We'll find the inlayers. Inlayers means the points which are fit to be in the edge is known as inlayers. The point which are not fit to be in a line is known as outlier. Outlier concept we know. Outlier means the data which is not suitable for machine learning training is called outlier. Inlier is just opposite of outlier. So I'll randomly pick 2 points. I'll make a straight line out of it. I'll find the distance and I'll consider whether the point is fit to be in a straight line or not. I'll choose how many other edges fit. If I have enough inlayers, then I'll keep the line. If not, I won't keep that. The last concept is vanishing point. Okay, first understand the vanishing point. So in this image, we have parallel edges. The road is given. In real time, the road will not vanish, right? So you see this image, the every end of the road is a parallel line. The side of the road is a parallel line. It is continuously straight. So if you take a picture of it at one point in an image, it ends, right? So both the parallel lines are ending at a one point. That point is known as vanishing point. So I can use again I have transform. Use I can vote to find the edge point. A better approach is to use the pair of lines directly to estimate the candidate vanishing point. So take a two parallel lines and identify the end point of it. That would be the vanishing point. So the complete application of this entire concept is rectangle reduction. So in rectangle reduction, we are going to use this approach. So we'll find the edges and then we can find the straight line using either successive approximation or half transform or vanishing point to determine the straight lines, and I can process the image further. That's all. Thank you.